This example applies the idea of the steady state approximation to calculating the concentration of a reactive intermediate, in this case this intermediate D, in a sequence of elementary steps. And the idea of elementary steps is the reactions occur as they're indicated, namely a molecule of A collides with a molecule B to make this intermediate D. And elementary steps also means we can directly write down rates of reaction. In this case, the forward rate is proportional to the concentration of A and the concentration of B. It's a two-step sequence where the overall reaction is A plus B goes to F. And I've indicated the rate constant we use in the calculation. The idea of the steady state approximation is that the concentration of D is low because it's a reactive intermediate and so reacts quickly, and therefore it quickly gets to some steady state concentration. And so we can apply this idea then of the steady state approximation by saying the concentration of D is not changing with time. And so we can write down that the change in the concentration of D respect to time is equal to 0, and then we can list the three reactions. We're making D in the first reaction, and it's first order in A and first order in B because elementary steps. D can also decompose back in the reverse reaction, so negative sign, rate constant, concentration of D, and then D can react away, rate constant 3, concentration of D. The steady state approximation, then, since this is 0, we can solve for the concentration of D in terms of these rate constants, K1, concentration of A, concentration of B, over K2 plus K3. And this means then we can calculate the overall rate of reaction. For example, the rate of forming the product F is K3 times the concentration of D, so K1, K3, concentrations of A and B. So this means the rate formation of product, we expect some rate constant, which of course in general we have to measure, and first order A and first order B. So use the reaction mechanism and the steady state approximation. This is how we expect the rate of product formation depend on the concentration of A and B.